Hello, how you doing? Have you seen how easy it is to implement an MP Neuron using Python and PyTorch? Well, if not, then watch along with me for the next few minutes and I'll quickly get you up to speed. Okay, let's get started. Before we get into the PyTorch code of an MP Neuron implementing a simple logic gate, you can quickly review the basics of an MP Neuron in this video I created earlier. I provide a quick, high-level overview of the MP Neuron in this video. Additionally, if you're interested in the academic paper that introduced the MP Neuron, I shared a PDF link in the YouTube description. This academic paper by Warren McCulloch and Walter Pitts is titled A Logical Calculus of the Ideas Immanent in Nervous Activity. This paper was presented in 1943. In this code example, we will implement an MP Neuron behaving as an AND gate implemented using PyTorch, which is an open source Python machine learning library. Here's the truth table for an AND gate. You can see to implement an AND gate, if both inputs are 1, then the output is 1. Otherwise, the output is 0. Quick note that there's no notion of training in the MP Neuron. In 1943, McCulloch and Pitts had not conceived of this idea. So in the MP Neuron, the implementer must set the weights and thresholds manually. So to implement an AND gate using the MP Neuron, you will need to set the weights and thresholds as follows. The input weights W1 set to 1 and W2 set to 1. Then set the threshold value to 2. So let's look at the Python PyTorch implementation of an MP Neuron for an AND gate. So in this Python script, you can see the Python dependencies imported first. I import the PyTorch library. I include information on this in the README file, which is part of the GitHub project. The GitHub project URL can be found in the YouTube description for this video. Next, I declare a Python class named MP Neuron implementing the AND gate. The init constructor sets 2 inputs with a weight of 1. It then sets the threshold to a value of 2. Next, I override the forward method and put in my own activation logic. The input vector x is element-wise multiplied by the weight vector. The resulting values are summed to calculate the weighted sum. Next, the weighted sum is compared to the threshold. If the weighted sum is greater than or equal to the threshold, the MP Neuron is activated and fires the output of value 1. Otherwise, it outputs a value of 0. Now we instantiate our declared MP Neuron AND class. As I referenced earlier, the 1943 MP Neuron does not include the concept of training your model. So we define our weights and thresholds in advance, and you saw me do this here in the constructor for the MP Neuron AND class. Now we define our test data. We have 2 inputs, and we define test vectors which represent our inputs to the MP Neuron with all possible combinations of 0 and 1. Next, we invoke our MP Neuron 4 times with our test data. The response contains a 0 or 1 based on whether the MP Neuron was activated or not. Lastly, we print out the results. Here we can see the results of our 4 tests, and we see that indeed the MP Neuron results match our AND gate truth table results. Therefore, we've confirmed that this MP Neuron implements an AND gate. Okay, feel free to download this Python code. The GitHub URL is in the YouTube description, and you can see how easy it is to implement an AND gate with an MP Neuron using PyTorch. If you look at the GitHub project, I also included an example of an MP Neuron implementing an OR gate as well as a NOT gate. Okay, thanks for watching. This video, along with all the other videos in this playlist, are listed in the YouTube description. I invite you to watch other videos on my channel. If you like the way I'm sharing this content, please consider subscribing. When you subscribe, this really helps my channel grow. One last thing. We all love technology, and we're all excited about all the innovation with the cloud and machine learning and AI. But don't forget to carve out some time to live in the real world. Go outside, go swimming, go hiking. go surfing, go climbing, but get out and move your body. And if you do, let me know in the comments. I want to hear about it. And with that, have a great day. Thanks.